So again, the reconstruction, the slope at the cell I can be reconstructed as ui minus 1 divided by delta x times phi of r, where r is the ratio of ui plus 1 minus ui and ui minus 1. Okay, and basically we want to construct the nonlinear functions of phi. And phi has to be nonlinear because it has to satisfy all these weird constraints. Okay, so I'm going to give you examples of 3 kinds of limiters. First of all, the min mod limiter. The min mod limiter is basically going as low as you can in the viable space. So phi of r is equal to a function like this. R phi, it goes straight to 1 and stays at 1. 1, 1. And of course, when r is negative, what should phi be? 0, yes. So that's the min mod limiter. It's a piecewise linear function. When r is less than 0, it's 0. When r is between 0 and 1, it is equal to r. And when r is greater than 1, it is equal to 1. The min mod limiter is applying the most conservative reconstruction possible, or doing the reconstruction that has the minimum slope possible. Okay, right? Because if you look at the constraints, if you go below the min mod limiter, it is no longer going to be a second order scheme. Okay, so that's the min mod limiter. And another limiter is the opposite, we call super B. It's going as high as possible. Its phi of r is equal to a function like this. It goes all the way to 2. And okay, at r equal to 1, it has to be equal to 1, but in the middle it goes like this. It's also a piecewise linear function, but it's split up into 1, 2, 3, 4, 5 pieces. And it is following the upper boundary of the viable region of a limiter. Okay, and that means I'm going to take the most aggressive reconstruction possible, or reconstruct the steepest slope I'm allowed to. And we're going to see a little bit later like what the effect is. And there is also a compromise between them. It's called the Van Leer limiter. The Van Leer limiter is phi of r is equal to, of course, when r is negative, it's 0, and when r is positive, it's a smooth function that goes through the viable region. So when r is equal to 1, it's equal to 1, and it's a function that goes like this. The exact formulation of r is of this function is 2r divided by 1 plus r. Okay, so when r is small, it is basically 2r. So it kind of follows the slope of 2 along the upper boundary of the viable region. When r is large, it is practically 2, so it goes all the way to the upper boundary also when r is large. But in the middle, it goes smoothly. There is no discontinuities. All right, there is no discontinuities in slope.